Alright, for Cl, it's 224. 242, sorry. 242, so we add them up to be 674, okay? We add this one, 70, total will be 674 kilojoules per mole. That's for reactants, okay? For products, now you see there are 2 moles. Alright, so I'll write 2 times, it's a bonding between hydrogen and chlorine. Okay, so again I check my periodic table. It hits here 427. So 2 times 427, 2 times 400 is 800, and 2 times 27, 54. So 854 kilojoules per mole. Now that we already find this, we substitute into this equation to get the enthalpy. So enthalpy is equals to what's that? Reactants minus products, 674 minus 854. Alright, so our answer will be a negative value. Okay, so let me do my calculator. 674 minus 854 minus 180. Okay, 180 kilojoules per mole. Okay, so that's how we calculate bond energy and then calculate enthalpy. Now you see, enthalpy is negative, so that means the reaction is exothermic, meaning it produces heat. It releases heat when hydrogen and chlorine reacts. It releases 180 kilojoules of energy. Alright, so now what if you are asked to plot the energy profile diagram? To plot it, this one gives us the idea. It's negative, so we know that for exothermic reaction, the reactants are at the top, the products are below. So when I draw this energy profile diagram, it will be like this. Okay, that's for exothermic reaction. And then this one, that's the enthalpy, that's equals to minus 180 kilojoules. And this one is the products, 2 HCl, and the reactant H2 plus Cl2. Energy and reaction. Okay, so that's how you calculate bond energy, find enthalpy, and then plot the graph. Alright, so I'll show you another example. Let's see the timing. Okay, another example. What if we have a reaction like this? H2 plus N2 produces NH3. Balance the equation. 2, 6, 3. Okay. Reactant, product. We calculate the enthalpy. Enthalpy is equals to H of reactant minus H of product. When you do that, H of reactant, we have to find this one, balance equation. So you see there are 3 moles, so 3 times reactant. Let's see, 3 times H2. Okay, 3 times value is 432. 32. So we should get about 1064. Oh wait, 1264. Okay, so let me prove. 3 times 432. No, 1296. And this is kilojoules per mole. That's okay. For the products, that's one. You see there are two. This one and this one. Okay, we add it with N2. That's N triple bond. Okay, for this one it's 945. So you write 945. Okay, get a total, add them up. Plus 945. So the total is 241 kilojoules. That's for the reactant. All right, now let's find for the products. This one, 2 mole times, now you see NH3, yeah? So then 1, 2, 3. So it's the bonding between nitrogen and hydrogen. Okay, so how many nitrogen? 1, 2, 3. So it's 1 bonding, 2 bonding, 3 bonding. There are 3 of them. So we're going to write 2 times 3 times NH bond. Okay, so 2 times 3 is 6 times NH. All right, according to this one, NH is 391. 391. 3 times 6 times 26, 6 times 54, and 4 carry on 5, 18, 23. Okay, that's for the products. Okay, let me push the calculator. 9, oh, 391, yeah. 391 times 6. Okay, 2346, that's correct. Now that we have already calculated for the product and reactant, okay, so now we'll substitute into this equation. So we have, let me write over here, equals reactant 2241 minus 2346. Okay, so 2241 minus 2346. Okay, so we get minus 105. 5 kilojoules per mole. Okay, again, enthalpy is negative, so the reaction is exothermic. To plot the graph, this one tells us it's exothermic. Okay, energy, products at the reactant at the top, products below. Okay, and then you put all this information, distance, enthalpy minus what's that? 105. And 2NH3 and 3H2 plus N2. Okay, finish. So that's how you calculate bond energy, calculate the enthalpy, and plot the graph. That's all, and please like, share, and comment, and we'll see you again in our next video. Adios.